Hello my friends, and welcome back to the You Can Do TV channel. In today's video, we will explore the construction of one of the world's largest airports in Türkiye. In other parts of the video, we will explore the world's leading modern construction equipment and technology. Crushed rock is an essential material of construction, leveling, and road construction works. In this section, we will visit the US-based Rogers Group's Whites Creek Quarry to explore the manufacturing process of crushed rock. The first phase of the process is drilling and blasting. A blaster lays out a specific pattern of shots to ensure the correct amount of explosive force is distributed evenly in the holes. This pattern helps to create safe blasts and reduce vibration. A subcontract drilling company is then called in to drill the holes, which usually takes around 2 days. After drilling, the holes are loaded with explosives and connected with electronic blasting caps. The electronic blasting caps enable precise control over the timing of the shots, ensuring each hole goes off milliseconds apart, minimizing vibration and improving the overall effectiveness of the blasting. The next step is loading and hauling the material from the muck pile to the primary crushing station. This is accomplished using large haul trucks with a capacity of 260 tons. The trucks are loaded either with a front-end pit loader or a track loader. They transport the material approximately 1,500 feet to the primary crusher. Crushing and screening are crucial stages in the production of crushed rock. The process is broken down into several steps. The primary crushing begins with a 42 by 48 jaw crusher. The material from the haul trucks is dumped into a primary crushing hopper. A grizzly feeder pre-screens the rock, allowing only material larger than 5 inches to enter the primary crusher. The jaw crusher breaks down the rock from a size of 3 to 4 feet to 8 to 12 inches. The crushed material is then conveyed out of the pit and into a surge pile. The surge pile acts as a buffer, ensuring the primary crusher operates efficiently, regardless of the processing plant's workload. It also serves as a storage area for future processing. From the surge pile, the material undergoes secondary processing. Conveyors transport the material out of the surge pile to a scalping screen, which separates the rock into different sizes. Anything larger than 3 inches is sent to a 5.5 cone crusher, which further reduces the size of the rock. The material is then sent to an April 20th triple-deck sizing screen, where it is sorted into different sizes. Anything larger than 1 inch goes to the tertiary crusher, while smaller material continues to the processing line or wash plant. The trucks are directed to appropriate piles for loading. A Volvo 220 front-end loader fills the trucks with the desired material. Typically, 3 scoops of material are sufficient to fill 2 to 3 ton loads. The Whites Creek Quarry produces various products to meet different construction needs. The primary product is number 57 stone, also known as 3/4, which is primarily used in concrete. Other products include crusher run, number 7 stone, 1/2 inch, for asphalt plants, riprap for erosion control, and number 1 stone for erosion control. The leveling process for the Istanbul Airport project was an enormous undertaking that played a critical role in transforming the sprawling site into one of the world's largest airports. Spanning a staggering area of approximately 76.5 million square meters, the project aimed to create a state-of-the-art airport facility capable of meeting the growing demands of the region. The leveling process involved extensive earthwork and grading activities, which required careful planning, advanced machinery, and skilled operators to achieve a uniform and suitable ground surface for subsequent construction phases. The site itself presented a host of challenges, including uneven topography and varying soil conditions. The leveling process had to address these obstacles and create a consistent ground level that could accommodate the construction of runways, terminals, and other vital airport infrastructure. To achieve this, a comprehensive approach was adopted, employing advanced surveying techniques and cutting-edge machinery to ensure precision, efficiency, and optimal results. The first phase of the leveling process involved site clearance, which entailed the removal of vegetation, rocks, and other obstructions. This meticulous clearance was necessary to provide a clear and unencumbered canvas for the subsequent earth-moving activities. Additionally, it facilitated the identification and protection of environmentally sensitive areas within the project site. Once the site was cleared, the leveling process progressed to the excavation phase. Vast quantities of soil needed to be moved to create a balanced cut and fill situation, where excess soil from higher areas was redistributed to fill lower areas. This approach aimed to minimize elevation variations across the site and establish a consistent ground level, crucial for the smooth operation of the airport. The excavation phase required the deployment of an extensive fleet of earth-moving equipment, including heavy-duty bulldozers, excavators, and graders. These formidable machines worked in harmony, orchestrated by skilled operators, to cut, shape, and redistribute the earth according to the design specifications. Their sheer power and precision allowed for the removal of millions of cubic meters of soil, which was transported and utilized in the leveling process. To ensure accuracy and adherence to design specifications during the leveling process, advanced surveying techniques were employed. Global Navigation Satellite Systems, GNSS, and total station instruments were utilized to establish precise control points and monitor elevation changes throughout the site. This real-time data was essential for maintaining the desired slope and gradient, enabling proper drainage and alignment of the airport infrastructure. The numbers associated with the leveling process for the Istanbul Airport project are truly staggering. It is estimated that approximately 85 million cubic meters of earth were excavated and transported during the course of the project. To put this colossal figure into perspective, imagine filling about 34,000 Olympic-sized swimming pools with the excavated soil. Such a tremendous volume of earth-moving operations showcases the magnitude and complexity of the leveling process. The challenges faced during the leveling process were further amplified by the sheer size and intricacy of the project site. Considerations such as the presence of underground utilities, environmental impacts, and the need to minimize disruption to surrounding areas had to be meticulously addressed. Environmental measures were implemented to mitigate the potential impact of construction activities, including the implementation of dust control measures and sedimentation management strategies. The successful completion of the leveling process was a pivotal milestone as it laid the foundation for subsequent construction activities. Once the site was expertly leveled and prepared, the construction of the airport's runways, taxiways, terminal buildings, and other critical infrastructure components could commence. The Istanbul Airport project, upon completion, aimed to boast an impressive 6 runways, multiple terminals, and a staggering capacity to handle around 200 million passengers annually. The Istanbul Airport project is an immense undertaking that involves extensive construction across various components of the airport. One remarkable aspect of this project is the sheer volume of construction required, particularly in terms of concrete production. The total construction volume for the entire project is estimated to be significant, with an astounding 7 million cubic meters of concrete being produced. This staggering figure highlights the scale and magnitude of the construction efforts undertaken to bring the airport to fruition. To put this into perspective, it can be compared to the construction of the famous Empire State Building in New York City. The Empire State Building, an iconic skyscraper, is approximately 443.2 meters in height and was built using around 200,000 cubic meters of concrete. In other words, the concrete production for the Istanbul Airport project is equivalent to the concrete volume used in constructing 35 Empire State Buildings. Such a massive amount of concrete production underscores the extensive infrastructure development required for the airport. It encompasses not only the terminal building and air traffic control tower, but also the construction of runways, taxiways, aprons, parking facilities, and various support structures. The air traffic control tower will serve as the central command center for managing aircraft movements and ensuring safe operations within the airport's airspace. It will be equipped with advanced communication and surveillance systems to facilitate efficient air traffic control. The tower's design will incorporate the latest technologies and conform to international standards for air traffic management. Adjacent to the air traffic control tower, the terminal building is also underway. The terminal building, designed to accommodate the growing demand for air travel, spans an impressive area. With a total floor space of approximately 1.3 million square meters, it will feature multiple levels, including arrivals, departures, and transit areas. The terminal is expected to have a capacity of handling around 90 million passengers annually, providing a seamless travel experience with modern amenities, retail spaces, and dining options. Furthermore, the Istanbul Airport project has prioritized sustainability and environmental considerations. The terminal building will feature energy-efficient systems and incorporate renewable energy sources to reduce its carbon footprint. The project aims to achieve Leadership in Energy and Environmental Design certification, emphasizing its commitment to eco-friendly practices. One of the primary objectives of the road construction process is to create a smooth and safe transportation route for passengers, employees, and cargo vehicles. Extensive surveys and analyses are conducted to determine the most suitable road alignments, considering factors such as traffic flow, connectivity to major highways, and environmental considerations. The Istanbul Airport project aims to construct several main access roads leading to the airport, along with secondary roads within the airport premises to facilitate internal transportation. These roads are designed to accommodate high volumes of traffic, including heavy-duty vehicles, and provide convenient connectivity to nearby urban areas. During the construction process, various tasks are undertaken, including land clearing, earthwork, grading, drainage system installation, and pavement construction. Advanced machinery and equipment, such as excavators, bulldozers, graders, and pavers, are utilized to carry out these tasks efficiently and effectively. The Istanbul Airport project includes the construction of approximately 50 kilometers of main access roads, comprising multiple lanes in each direction to ensure efficient traffic flow. Additionally, around 30 kilometers of secondary roads are planned within the airport premises to connect various terminals, parking facilities, and service areas. Asphalt paving works have commenced on runway 1 of Istanbul New Airport, which spans 3,750 meters in length and 60 meters in width. This milestone marks a significant step in the realization of the airport project with utilizing modern techniques and equipment. Moreover, ensuring the safety of the roads is of utmost importance. Road markings, signage, lighting, and barriers are strategically installed to guide drivers and enhance visibility, especially during nighttime or adverse weather conditions. Additionally, safety measures like guardrails and pedestrian walkways are implemented to protect road users. The local 528 cement masons and plasterers in Seattle recently undertook an impressive high-rise concrete pour that showcased their expertise and the scale of their work. With a deck spanning approximately 10,000 square feet, this pour was no small task. A high-rise concrete pour is a significant milestone in the construction of a building, as it lays the foundation for the entire structure. The concrete acts as the structural support, providing stability and strength to the building. Prior to the pour, the construction site was meticulously prepared. The necessary framework and reinforcement were installed to support the weight of the concrete. Once the preparations were complete, the concrete trucks began arriving one by one. These massive vehicles carried the freshly mixed concrete. The cement masons worked in unison, directing the flow of concrete and ensuring it was evenly spread across the deck. The cement masons utilized a range of specialized tools to manipulate and refine the surface of the poured concrete, ensuring a level and uniform finish. These tools are designed to facilitate the smoothing and shaping of the concrete, resulting in a durable and aesthetically pleasing surface. Trowels are one of the primary tools used by cement masons during the finishing process. They come in various sizes and shapes, including hand trowels and power trowels. Hand trowels have a flat metal blade attached to a handle, allowing masons to manually smooth the surface of the concrete. Power trowels, on the other hand, are mechanical tools equipped with rotating blades that efficiently cover larger areas of concrete. By running the trowel over the concrete, the masons are able to eliminate imperfections and create a smooth, polished appearance. Floats are another essential tool in the cement mason's arsenal. Floats have a flat, rectangular, or square surface made of wood and aluminum. They are used to level and smooth the concrete surface by eliminating high spots and filling in low areas. Floats can be used in both wet and dry stages of the concrete, allowing the masons to achieve the desired texture and finish. Screeds are employed during the initial stages of the pour to level and flatten the concrete. A screed is a long, straight board or bar that is dragged across the surface of the wet concrete. By pushing and pulling the screed along the guides or formwork, the masons distribute the concrete evenly, removing excess material and creating a uniform thickness. This process ensures that the concrete is level and ready for further finishing. Once the concrete has been poured and leveled, it undergoes a crucial process of hardening and curing. After approximately 4 hours, the concrete reaches a stage where it has hardened enough to support the weight of the workers. At this point, the cement masons employ concrete power trowels and hand trowels to further refine the surface and achieve the desired finish. Concrete power trowels are mechanical tools that consist of rotating blades attached to a motorized base. These machines are used to cover larger areas efficiently and produce a smooth and polished surface. The power trowel is guided by the workers, who control its movement and pressure to ensure an even and consistent finish. The blades of the power trowel rotate rapidly, effectively compacting the surface and removing any imperfections or air pockets in the concrete. By carefully maneuvering the power trowel across the concrete, the workers achieve a dense and durable surface with a uniform appearance. While power trowels are excellent for large-scale concrete pours, hand trowels play a crucial role in refining smaller or hard-to-reach areas. Hand trowels consist of a flat metal blade attached to a handle, allowing the workers to manually smooth and shape the concrete. With precise control and skill, the workers use hand trowels to fill in low spots, eliminate high spots, and create a level surface. Hand trowels are particularly useful in corners, edges, and areas that cannot be reached by power trowels. Gomaco equipment utilizes innovative concrete slipform paving technology to construct roads with precision and efficiency. The process begins with the preparation of the subgrade and the installation of guiding systems, including string lines or 3D machine control, to ensure accurate alignment and grade control. Once the setup is complete, Gomaco's equipment is brought into action. At the core of Gomaco's Slipform paving technology is the Slipform paver, a specialized machine designed to continuously extrude and shape concrete. The machine moves forward at a controlled pace, guided by the predetermined path. The Slipform paver is equipped with a mobile chassis and an adjustable paving mold. As the machine advances, 2 concrete mixer trucks pours the mixed concrete directly in front of the Slipform paver. The machine's mold receives the concrete and distributes it evenly across the width of the mold. Gomaco's Slipform paver incorporates various mechanisms to shape the concrete as it is extruded. Hydraulically adjustable side forms confine the concrete and define the desired shape of the road. Tamper bars and vibrating screeds work together to compact and finish the concrete surface, ensuring proper density and a smooth, level pavement. Augers are utilized to distribute any excess concrete evenly and provide lateral support to the machine. To maintain precision and accuracy, Gomaco's Slipform pavers are equipped with advanced control systems. These systems employ sensors and feedback mechanisms to monitor the machine's position, speed, and other critical parameters. Real-time data processing allows the machine to make necessary adjustments, ensuring the desired profile and surface finish are maintained throughout the paving process. Curb roller manufacturing is revolutionizing the construction industry with its innovative Hydra-Screed, a powerful and efficient tool that simplifies the process of screeding shed floors. The Hydra-Screed, powered by the Hydra Pack, offers an unparalleled level of control and precision, ensuring a perfectly flat and even surface every time. One of the standout features of the Hydra-Screed is its use of a rail system. This rail allows the screed to float effortlessly across the floor, eliminating the need for manual labor and reducing operator fatigue. The smooth movement of the screed, combined with the power of the Hydra Pack, guarantees a superior finish that is both visually appealing and structurally sound. With the Hydra-Screed, bull floating and finishing become a breeze. The powerful Hydra Pack provides consistent and reliable performance, allowing contractors to complete their projects efficiently and effectively. This advanced technology takes the guesswork out of the process, ensuring that even inexperienced operators can achieve professional, grade results. Not only does the Hydra-Screed deliver exceptional performance, but it also saves time and labor costs. By streamlining the screeding process, contractors can optimize their workflow and take on more projects, ultimately increasing their profitability. Curb Roller's Hydra-Screed is a game changer in the construction industry, offering an easy and efficient solution for achieving perfectly leveled shed floors. With its cutting-edge technology and superior performance, the Hydra-Screed sets a new standard for quality and productivity in the field of concrete finishing. When it comes to achieving success in concrete projects, custom drums play a pivotal role in shaping the outcome. Curb roller manufacturing understands the challenges that contractors face, particularly in unique projects like drainage ditches, where multiple pours are often required. However, with custom drums, these hurdles can be overcome, leading to enhanced efficiency and superior results. By utilizing custom drums from curb roller manufacturing, contractors can eliminate the need for multiple pours. This eliminates the constant weather checking and uncertainty regarding the placement of different sections. With custom drums, each pour is precisely tailored to meet the project's specifications, ensuring a uniform and consistent finish. There are no inconsistencies, low spots, or the need for redundant cross-forming. The advantages of custom drums go beyond achieving a uniform finish. With the assurance of a reliable shaping solution, contractors can confidently allocate their crew to other projects, maximizing productivity and profitability. Custom drums offer a tailored and efficient approach to concrete shaping, providing contractors with the tools they need to deliver exceptional results. Railroad demolition projects require specialized equipment and skilled operators to efficiently and safely dismantle existing tracks and infrastructure. One such project took place at Paradeplatz in Zurich, where the Eberhard Company undertook the challenging task of removing the railway tracks. This case study explores the equipment utilized and the methods employed during the demolition process. The Eberhard Company employed a range of heavy machinery, including the CAT 395F and CAT 352F excavators, along with the CAT 329E loader, to facilitate the Paradeplatz railroad demolition. Each machine was equipped with specialized attachments designed to perform specific tasks. The CAT 395F excavator, fitted with a specialized bucket attachment, was utilized to shovel the road and rails. This robust bucket attachment, tailored for railroad demolition, had reinforced edges and teeth to withstand the demanding conditions. It allowed operators to efficiently scoop up the road and rail materials, making the process more time-effective. To chisel down the road, the CAT 352F excavator was utilized, equipped with a specialized hammerhead attachment. This attachment, designed specifically for breaking down hard surfaces, enabled the operator to methodically chip away at the road material, facilitating its removal. The precise control offered by the CAT 352F and the hammerhead attachment ensured accurate and targeted demolition. In addition, the CAT 329E loader played a crucial role in the project. Its primary task was to shovel sand onto trucks for disposal or reuse. With its sturdy construction and high lifting capacity, the CAT 329E loader efficiently loaded sand into trucks, ensuring a streamlined process for material removal. The Paradeplatz Railroad demolition project followed a systematic approach. First, the CAT 395F excavator with the specialized bucket attachment was used to lift the road and rails, allowing for easier access to the underlying infrastructure. Simultaneously, the CAT 352F excavator, equipped with the hammerhead attachment, chiseled down the road, breaking it into manageable pieces. Once the road was sufficiently dismantled, the CAT 329E loader came into action, shoveling sand onto waiting trucks. This step ensured efficient disposal of the excavated material, clearing the way for further progress. The loaders were also responsible for transporting necessary supplies and equipment to the site, contributing to the overall project logistics. The construction of the Istanbul Airport project involves a significant volume of work and various components, each contributing to the overall functionality and success of the airport. The utility and infrastructure systems of the project entail the construction of extensive networks, including approximately 200 kilometers of water supply pipelines, 150 kilometers of sewerage systems, and 250 kilometers of electrical grids and telecommunications infrastructure. These systems are designed to efficiently supply water, manage waste, and provide reliable power and communication throughout the airport complex. The utility and infrastructure systems include water supply networks, sewerage systems, electrical grids, and telecommunications infrastructure. The construction of these systems ensures the efficient flow of essential resources throughout the airport complex, supporting the needs of passengers, airlines, and airport personnel. The installation of the baggage handling systems is a critical aspect, with the project incorporating state-of-the-art technology. It includes the installation of approximately 20 kilometers of conveyor belts, advanced sorting mechanisms, and security screening equipment. These systems are capable of handling a staggering volume of luggage, processing an average of 30,000 bags per hour. To accommodate the needs of passengers and airport users, the project involves the construction of expansive parking areas. This includes the development of multi-level parking structures capable of accommodating over 40,000 vehicles, as well as open-air parking lots with a capacity of more than 20,000 vehicles. Additionally, designated areas for short-term and long-term parking are being created, providing convenient options for travelers and airport staff. The construction of hangars and maintenance facilities is another crucial aspect of the project. It includes the construction of multiple hangars with a combined area of over 100,000 square meters, capable of accommodating a large number of aircraft simultaneously. These facilities are equipped with advanced maintenance equipment and technologies to ensure efficient servicing and repairs of the aircraft. The Istanbul Airport project also places a strong emphasis on landscaping and environmental considerations. It involves the creation of lush green spaces, gardens, and recreational areas spanning approximately 300,000 square meters. These areas not only enhance the aesthetic appeal of the airport, but also provide a pleasant environment for passengers and visitors. In terms of tunnel construction, the project includes the development of tunnels for transportation and maintenance purposes. These tunnels span a total length of approximately 10 kilometers and serve as vital passageways for vehicles, personnel, and utility systems within the airport complex. To ensure the efficient operation of the tunnels, the project incorporates the installation of comprehensive mechanical, electrical, and plumbing systems. This includes the implementation of advanced ventilation systems, over 100 kilometers of electrical wiring, and plumbing networks that span the entire tunnel network. These systems provide optimal lighting, air quality, and utility services to support smooth operations and maintenance activities. The construction of the fuel transfer system is a significant undertaking, involving the installation of underground pipelines with a total length of approximately 15 kilometers. These pipelines connect the fuel storage tanks, which have a collective capacity of over 5 million liters, ensuring a reliable and efficient fuel supply for aircraft operations. Additionally, a fuel station equipped with multiple fuel tanks is being constructed to meet the refueling needs of ground vehicles at the airport. As the demand for electric vehicles continues to grow, the Istanbul Airport project includes the installation of electric charging systems. This entails the deployment of over 200 electric charging stations strategically placed throughout the airport complex, enabling passengers and airport personnel to conveniently recharge their electric vehicles. The communication and network systems of the project encompass a comprehensive infrastructure. This includes the installation of over 1,000 kilometers of fiber optic cables, wireless connectivity across the entire airport area, and the implementation of advanced voice communication systems. These systems facilitate efficient and reliable communication between airport staff, airlines, and passengers, ensuring seamless operations and information flow. The construction of an operation control center is a pivotal aspect of the project, serving as the central hub for monitoring and managing airport operations. Equipped with cutting-edge technology, surveillance systems, and communication networks, the control center provides real-time monitoring, decision-making, and coordination. It encompasses an area of approximately 5,000 square meters and houses a dedicated team responsible for ensuring the smooth functioning of the airport. The Istanbul Airport project is one of the largest and most ambitious infrastructure developments in recent history. The first phase alone was completed in a record-breaking timeframe of just 42 months, showcasing the sheer scale and efficiency of the project. With an estimated cost of around 10 billion euros, the Istanbul Airport project has attracted attention from around the world. It has been hailed as an architectural and engineering masterpiece, showcasing Turkey's commitment to developing world-class infrastructure. Upon completion, the Istanbul Airport is expected to have a total annual passenger capacity of around 200 million, making it one of the largest airports in the world.